PC Calculus students, this video is about 6 most popular series. You are supposed to memorize them, know them very well, and I'm going to walk through all 6 series. So first series in the series of series is Taylor series. We have known this as a Taylor polynomial. Taylor polynomial of a function f, we are going to write it as a series. So know the difference between polynomial and series. Polynomial, we write it as p sub n of x, and n is a degree. If it says nth degree polynomial, that means you have to stop at that power. Series is very similar, but it keeps going forever. So same as f of c, f prime of c, this is the first degree, second degree term, then 3 dots to show that it continues. This is the general term, nth power general term. And if we put all of them together as a summation notation, there are 3 dots which tells you it goes to infinity. And this is the general term. So know that the function f of x can be approximated using polynomial, but why stop at polynomial? Why can't we go up to infinite many terms? And we call it the series infinite many terms. So typically, you have to write few terms, 3 dots, general term, plus 3 dots to show that it keeps going forever. So know the difference between polynomial and series. If c is equal to 0 is called Maclaurin series. So number 2 is a Maclaurin series. So I'm going to write the Maclaurin series. What's the Maclaurin series is f of 0, f prime of 0, x prime of 0, x square over 2 factorial. You can see, keep going. And the general term would be nth derivative at 0, x to the n over n factorial. And yes, it starts with a 0 to infinity. So this is a Taylor series, Maclaurin series. Partial sum of the Taylor series is called Taylor polynomial, which I just explained, and how we write it, nth term. So be careful. First thing, you have, anytime you write the polynomial, you have to write some few terms up to the nth degree, and series means you keep going, and the general term. Typically in AP exam, they ask 4 plus general. So know that the general term has nth derivative over n factorial. That's the coefficient. Again, these are also called power series. Why we call them power series? Because we have a power of n. So they are Taylor series, they are Maclaurin series, but they are also called power series. So we need to know the following Maclaurin series and their interval of convergence. So let's talk about these 4 very popular ones. Memorize them, know them very well. Usually I give an index card in the class, and I give a memorization quiz also in the class, so that students know how to rewrite. I would recommend that you write again on a paper, so that you know them cold. Know them cold means without warm up, you know them, and make sure you can't forget them. So here is my hint how to remember, or tips how to memorize this series. E to the x is always start with a 1, because e to the 0 derivatives, all e to the x, all the derivatives are e to the x, but e to the 0 is always 1. So coefficient is always 1. You can see that all those coefficients are always 1. Second thing, e to the x is positive, so all the terms are always positive. All the terms are always positive. X to the n over n factorial is my general term. So you can never forget e to the x. That's very easy, very popular one. Make sure you know them. There are no negative terms, all positive terms. The second one is sine of x. This, I mean, not second, 1, 2, 3, 4. fourth one is sine of x. Sine is a odd function, so you can also say that all the powers are odd. 1, 3, 5, 7. Divide by 3, 5, 7 factorials. We already know how do we derive this. We have learned that. Sine is the one always start with the first one, x, minus, plus, minus, alternate sign. So let's talk about the general term. General term is again important because you will have a special point for general term. Typically 4 plus general term. Series is 4 terms plus general term. So negative 1 to the n is the alternator. It gives you alternate sign. X to the 2n plus 1. So 1, 3, 5, 7 are odd numbers, which is 2n plus 1, n over 2n plus 1 factorial. Another way to remember is the sign is this function, and you can see that the first term is always x. The first term, because that's your tangent line, is always x. So sine series starts with x. You can never forget that. That's because the tangent line at 0 is always y equal to x. Okay, so fifth one is a cosine. Cosine is derivative of sine is a cosine. You never make a mistake. Derivative of x is a 1. Derivative of x cube is 3x square over 3 factorial, which you simplify. You get x square over 2 factorial. X to the fifth is 5x to the 4 over 5 factorial. 5 and 5 factorial, one of the 5 get cancelled and you get this. So derivative of sine is a cosine. So do not get confused between sine and cosine. Always remember one of them. You can easily find the derivative term by term and get the cosine x. Another way to remember is also cosine x graph starts like this, and first degree tangent line is always 1. Tangent line at 0, that's my first degree term, is always 1. And that's my cosine term. Again, we have alternator, even number. This is a 0 power. You can say x to the 0. So 0, 2, 4, 6 are even number. Be careful here. You must have a parenthesis. Factorial is must have a parenthesis. So e to the x, sine x, cosine x. Normally students always get it because odd number, odd power, even number, even power, even function. You can say that. And e to the x is all positive ones. So don't forget them. Now let's talk about the last one is a sixth one, which is a geometric series, is also power series. They are all called power series as well because of the power. But these are transcendental function. E to the x, sine x, cosine x are transcendental function. 1 over 1 minus x is geometric series, which is expanded form is a over 1 minus r. A is the first term, common ratio is x, and 1 plus x, x cube square, x to the third, and which is x to the n. So rational function, where often we have seen this in a free response question as well. You have to make a connection that this is a rational function. This is a geometric series, which is a power series, which is expanded form, and this is using summation notation. So manipulation, we are using this geometric series many times. So that's the not a transcendental function. And interval of convergence is always absolute. X has to be less than 1, which means interval of convergence is -1 and 1, and ratio is 1. So know this 6 series very well, just like comparison test. We know this very well so that we can use them in manipulation techniques. Now you can only manipulate if the center is a 0. You can only manipulate if center is 0. So all you can see, they are all Maclaurin series. They are not Taylor series. Taylor series at center 0, but Maclaurin series center is 0, then only we can use them to manipulate. So in this, the known series we manipulate based on, we can sometimes substitute We can multiply, divide series by a given expression. We can add, subtract two series. Integration and derivative, that's the very important concept. You can integrate term by term. We know that sine of t over t is an impossible integral, but if we can rewrite as a sine of t as a series we use and then divide by t, we can integrate, we can find derivative, we can recognize as a sum of a geometric power series. A lot of things we can do, and you must know those 6 series before we use them.